Hello students, in today's session, we'll solve and learn a lot of things about the chapter Real Numbers, which is one of the most important topics for mathematics. So let's start and let me just share my screen. Okay, so here we start with the chapter Real Numbers. Isn't numbers, you think, the most interesting thing about maths? I think so. Maths is all about numbers as well as practicing. The more numbers are there, the more complicated the maths is. But the more you practice, the more easy maths becomes. Did you know that there are two types of numbers? Mainly two categories of numbers are there. The two types are real number 1 and second one is the imaginary number. Real numbers can be further divided into rational number as well as irrational numbers. And imaginary numbers are something that are roots of negative numbers, which we don't need to understand at this particular standard. We'll understand this in higher standards. The real numbers are something that we'll learn in this chapter. Now, real numbers are divided into two subcategories, that is rational number as well as irrational numbers. Okay, now let's move on to the next. Real numbers are a subset of the complex number. Okay, so 0 is by definition a complex number and a real number also. 0 is a complex number also and a real number also. We'll now see that just as a fraction, it's written here, just as a fraction is rational number and a real number. Fraction is also a rational number, which is a subcategory of real number. So we'll call fraction as rational number as well as real number. Okay, as we studied in the previous slide, real numbers are divided into two rational and irrational numbers. You can see this chart if I zoom it a bit. Yeah. So real numbers, rational number, irrational number. Now rational numbers are of two types, integers and non-integers. Integers are again of three types, that is negative integer, 0 and natural numbers. Then we have non-integers. Then irrational numbers are also positive and negative. Okay, so let's move on to the next slide. Okay. Rational number. A rational number is something, is a number such as -3/7 that can be expressed as the quotient or fraction. A fraction is always in the form of p/q, where p is the numerator and q is the quotient of two integers. And q is always a non-zero number. Okay. Okay. So to understand real numbers more precisely, more briefly, we'll understand a theory which is Euclid's division lemma. You might be thinking that what it is, it's a very complicated name you might have heard, but no. It's a really easy term that we'll learn as we proceed, and let's see how it can be more interesting. It is basically used to find highest common factor. You must have heard about the HCF, LCM. See, so it's basically used to find out actually the highest common factor. So Euclid's division lemma and algorithm. Given two positive integer a and b, there exists unique integer a and r satisfying the equation a is equals to bq plus r, where r is more than 0 but less than b. Okay, I'll tell you what exactly this definition means. It means that there are two positive integers. And for those two particular positive integers, there exist two unique unique integers that are a and r. It means if we change a and b, then we also have to change a and r. These are the unique integers that are dependent on the positive integers a and b. Okay. For example, now I give you 7 chocolates and you have to put those chocolates in 3 bags. Okay. Or maybe if I give you, I give you 7 chocolates and you have to put 2 chocolates in each bag. Now, if I ask you, how many bags do you require? So what basically you will do is, you will divide 7 chocolates and 2, since 2 chocolates is to be put into one bag, so you will divide 7 by 2. So we get the question as 3. Now we can see that 3 bags are filled with 2 chocolates, which becomes 6, and 1 chocolate is still left. Okay. Now what is that 1? That 1 is the remainder. Okay. And 7 is the dividend, 2 is the divisor, and 3 is the quotient. Okay. Now what is this here? As we took A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. Now we put those example here. Okay. So A, that we took as 7 chocolates. So 7 is the dividend. B is the divisor, that is 2, because we have to distribute 2 chocolates. Quotient is 3, because we had overall 3 bags which has 2 chocolates each, and remainder is 1, because 1 chocolate was left that was not satisfying the value and it was left alone and it cannot be put in any bag. Okay, so here it is. Now, have you learned about algorithm? If yes, then it will be easy for you to understand the further class. If not, then I'll teach you from very basic. Let's learn about Euclid's division algorithm now. Okay. Algorithm. What is an algorithm? An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Okay, for example, if you have any problem, there is no shortcut to it, right? That this is the problem and you have the solution to it. No, it cannot be like that. You have each and every step by step, you solve this and then you find the answer to it. Similarly, this is an algorithm for which we have steps and then we find the solution to that particular problem. Okay. Euclid's division algorithm is a technique to compute the highest common factor, that is the HCF of 2 given positive integers. Okay. Now let us see how the algorithm works. Now, suppose we need to find the HCF of the integer 455 and 42. Now what is 455? It's the dividend. And what is 42? It's the divisor. We have to find the quotient as well as the remainder. We start with a larger integer, that is 455. Then we use Euclid's lemma to get it. Okay. Now 455, as I told you, is the dividend. 42 is the divisor. Now 10 is the quotient and the remainder was 35. Okay. This is the form in which we have written it, in the form of Euclid's lemma. Okay. Now consider 42 as the remainder, and 42 as the divisor, and remainder will be 35, and apply division lemma to get it. Now what we did here, before in the previous slide, 455 was the dividend and 42 was the divisor. Now what we did is, we made 42 as the dividend and the remainder is converted into the divisor. Okay. So 42 is equal to 35 into 1 plus 7. 7 is the remainder. Okay. And 42 is the dividend, 35 is the divisor, and 1 is the quotient. Now, in the next slide, can you guess what we'll do? Now we'll make 35 as the dividend and 7 as the divisor. We are solving this in a pattern. Can you see the pattern here? Like the dividend becomes the dividend becomes the, I mean, the divisor becomes the dividend and the remainder becomes the divisor. This is the pattern that we are following, right? Now consider the divisor to be 35 and the remainder 7 and apply division lemma to get it. Now we have 35 is equal to 7 into 5 plus 0. We have to solve this particular process until the remainder comes out to be 0. And this is the process how we find the highest common factor. Okay. Now, have you heard anything about fundamental theorem or arithmetic? Let's see how it works. Do you know how can a natural number be written? Let's see this also. The fundamental theorem of arithmetic is any natural number can be written as a product of its prime factors. For example, 2 is equal to 2 into 1. 4 is equal to 2 into 2. 4 is not the prime number, but 2 is the prime number. I hope you all know what is a prime number, which does not come in any numbers table, right? Now let's move to the next slide. Okay, find the LCM and HCF of 6 and 20 by prime factorization method. So 6 is equal to 21 into 31. We can find it by Euclid's division algorithm, and 20 is equal to 2 into 2 into 5 is equal to 22 into 551. Okay. Did the term irrational number ring a bell in your mind? Let's see to it. An irrational number is a number that cannot be expressed as a fraction for any integer. That means it cannot be written in the form of p by q. As we write the fraction, no? P is the numerator, q is the denominator whose value is always more than 0 or can't be 0. So irrational numbers are those which do not follow these rules. So thank you, students. After this, we'll learn in the next session. Till then, solve the problems related to this theory. And if you face any difficulty, we'll solve in the doubt class. Till then, keep practicing.